Question is just for the students studying for the higher tier chemistry paper. So what mass of carbon would be needed to reduce 200 grams of copper oxide? The first thing we do is we write the information from the question next to the equation. So we've got 200 grams of copper oxide, and then we write a sentence of the ratio of the reactants involved. So 2 moles of copper oxide react with 1 mole of carbon. It's a 2-to-1 ratio, and we get that from the balancing numbers in front of the formulas. Now we need to know how many moles of copper oxide we've actually got, and we use the equation moles is mass over mR. So the mass is 200. We now need to work out the mR, the formula mass or relative molecular mass of copper oxide, and we do that by adding up the mass numbers from the periodic table. So copper is 63.5, oxygen is 16, so the mR of copper oxide is 79.5. Notice at this stage we don't use the large balancing number, we ignore that 2 that's in front of it, because formula mass is only ever for one molecule. So we put the 79.5 into our equation, and to work out the moles is 200 divided by 79.5, which is 2.516 moles. And once again I'm going to write that next to the equation. Now we know the ratio is 2-to-1, so we'll have half as many moles of carbon compared to copper oxide. So if we divide that by 2, we get 1.258 moles of carbon. And it's worth writing that out because you will get a mark in the exam for calculating that. But we actually want to know the mass of carbon needed. So the mass is moles times AR. I'm using AR this time because I've got atoms rather than molecules. Carbon is on its own. So 1.258 times 12, which is the mass number for carbon, and we get 15.096 grams. Question 2. What mass of iron oxide would be needed to produce 100 tons of iron? So pause the video, have a go for yourself and see how you get on. Now it's in tons. We could go to the trouble of working out how many grams that is, or we could just imagine we're working it out in grams, and that's what we're going to do. Imagine the question said 100 grams instead of 100 tons. Now this time we want to know how much iron oxide is needed to produce a certain amount of the product. So again we write 100 tons next to iron, but we know we're going to work it out as if it's in grams. And then we're going to write the ratio. 2 moles of iron oxide makes 4 moles of iron. So to work out the number of moles of iron we've actually got, we use moles of iron is mass over AR. Again, it's AR because we're dealing with atoms, Fe. So that's going to be 100, imagine it's 100 grams, not tons, divided by 56, which is the relative atomic mass of iron. And once again, we're ignoring the 4 in front of it. AR is only ever for one atom of the element. So when we work that out, we get 1.786 moles. We put that next to the iron in the equation, so we know how many moles of iron we've got. And the ratio is 2-to-4. So we've got half the amount of iron oxide compared to iron in terms of moles. So the moles of iron oxide would be half of 1.786, and that is 0.893 moles. But we also need to work it out in grams. So mass of iron oxide is moles times mR. We know the moles is 0.893, but then we need to work out the mR of iron oxide. So we add up 56 and 56 for the 2 iron atoms, and then 3 lots of 16 for the 3 oxygen atoms. Again, we're ignoring the big 2 in front of it because mR is for one molecule of the substance, and that comes to 160. So we put that back into our moles equation, and we get 142.88. And at this stage we need to remember it should all be in tons, so we swap the grams out for tons. So our answer is 142.88 tons. If you found this useful, please give it a like and don't forget to subscribe so you don't miss out on future videos.